Ever wondered how we figured out the force of gravity, the reason planets orbit the sun, or even why an apple falls from a tree? It all comes down to one brilliant mind, Sir Isaac Newton. But what exactly is the use of Newton, beyond just being a name in a physics textbook? That's what we're diving into today. Now, Newton wasn't just one thing. He was a polymath, a genius who made groundbreaking contributions to mathematics, physics, astronomy, and even theology. We're going to focus primarily on his impact on physics, specifically his laws of motion and universal gravitation, and how they continue to shape our understanding of the universe. Think about it. Before Newton, the world was explained by a mix of philosophy and observation, often with a heavy dose of superstition. There were ideas about how things moved, but no real unifying framework, no concrete mathematical laws. Newton changed all of that. He provided the tools to not just describe motion, but to predict it. Let's start with his 3 laws of motion. These might seem simple at first glance, but their implications are profound. The first law, the law of inertia, states that an object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. In simpler terms, things tend to keep doing what they're already doing. A book on a table stays there unless you push it. A hockey puck sliding on frictionless ice will continue sliding at the same speed until it hits something. This might seem obvious now, but it was a revolutionary idea at the time. It challenged the prevailing Aristotelian view that a constant force was required to maintain motion. The second law is arguably the most famous, F equals ma. Force equals mass times acceleration. This law quantifies the relationship between force, mass, and acceleration. It tells us that the greater the force applied to an object, the greater its acceleration will be. It also tells us that the greater the mass of an object, the harder it is to accelerate. Pushing a shopping cart full of groceries requires more force to accelerate than pushing an empty cart. This law is fundamental to understanding how forces affect motion, and it's used in countless applications, from designing cars to launching rockets. The third law is the law of action and reaction. For every action, there is an equal and opposite reaction. This means that when you exert a force on an object, that object exerts an equal and opposite force back on you. When you jump off the ground, you push down on the earth, and the earth pushes back up on you, propelling you into the air. This principle is at play in everything from walking to rocket propulsion. Rockets expel hot gas downwards, and the reaction force pushes the rocket upwards. Now, these 3 laws are powerful on their own, but Newton didn't stop there. He also developed the law of universal gravitation. This law states that every object in the universe attracts every other object with a force proportional to the product of their masses and inversely proportional to the square of the distance between them. In simpler terms, the bigger the objects, the stronger the gravitational pull between them. And the farther apart the objects are, the weaker the pull. This law explained why planets orbit the sun. The sun, being much more massive than the planets, exerts a strong gravitational pull on them, keeping them in orbit. It also explained why the moon orbits the earth. And, famously, it explained why an apple falls from a tree. Newton realized that the same force that makes the apple fall is the same force that keeps the moon in orbit around the earth. This was a monumental leap in understanding. He unified the celestial and terrestrial realms, showing that the same laws of physics govern both. So, what is the use of Newton? Well, his laws of motion and universal gravitation are the foundation of classical mechanics. They are used in countless applications, from designing bridges and buildings to calculating the trajectories of spacecraft. They are essential for understanding the motion of everything from a baseball to a planet. But Newton's impact goes beyond just practical applications. He provided a new way of thinking about the universe. He showed that the universe is governed by mathematical laws, laws that can be discovered and understood through observation and reason. He helped to usher in the scientific revolution, a period of unprecedented intellectual growth and discovery. His work laid the foundation for much of modern physics. While some of his ideas have been refined and expanded upon by later physicists, like Einstein, his contributions remain fundamental. Even today, engineers, scientists, and students rely on Newton's laws to understand and predict the behavior of the physical world. Newton's work also had a profound impact on philosophy. His success in explaining the universe through mathematical laws inspired philosophers to seek similar explanations for other phenomena. He helped to promote the idea that the universe is rational and understandable, a concept that continues to shape our worldview. So, the next time you see a rocket launch, or an apple fall from a tree, or even just think about the planets orbiting the sun, remember Isaac Newton. His insights into the laws of motion and gravity have shaped our understanding of the universe in profound ways. He gave us the tools to not just observe the world, but to understand it, predict it, and even manipulate it. His legacy continues to inspire scientists and thinkers to this day. With that said, thanks for watching, and until next time.